Hello, everyday statistics, and welcome to lesson 2.8. We're going to be looking at fitting models to curve relationships. So before we were looking at a relationship between some explanatory and response variable, and we were fitting it into a linear association. Uh, and then we were able to use a least squares regression line in order to model that data. And then we've also found, looking at residual plots, that there is some types of data that do not work for least squares regression. And that's the type of data that we're going to look at today. So here we go. So these are the things we're going to do today. We're just going to get through kind of some basic sort of definitions, and then we're going to get right to work on showing you how to use your technology to create these models. So let's get right into it. All right, so we're going to be dealing with two types of models. We're going to be dealing with quadratic models, and we're going to be dealing with exponential models. So like I was saying, we're going to use this for our one of our non-linear associations. And it's going to be in that form, y hat equals ax squared plus bx plus c. And our calculator is going to, so we're going to be able to put in our explanatory and our response variables, and our calculator will tell us what A, B, and C are in this model right here. Right. So here's an example of a nonlinear relationship. And the reason why we're kind of identifying that is we can see that, the data kind of increases and then it starts to decrease. And while that's not a perfect fit, it's a better fit than if we were trying to model it with a line, because we have these points over here that are really just not following a linear pattern. And so there we go. They also chose to use a quadratic model for this as well. And this is what the model looks like, the equation. And you'll see this is your A, and then here you have B, and then you have C. And we'll figure out how to get all of these things to get output from our calculator. So the next type of model that we'll look at is an exponential model. And we'll get right to it right now. Okay. So here we go. It looks like we've got some data from Intel looking at years since 1970 and number of transistors. And you can see this is definitely an exponential model. So, and the way that we'll identify an exponential model is you'll see that there will be this relationship where it kind of stays flat, and then all of a sudden it's going to just increase really, really quick. And that's what we're looking for if we're going to identify something as an exponential model. Another exponential model that we could deal with would look like this. Of course, it's not matching this particular bit of data, but you could also have exponential decay. And exponential decay would be some data that was kind of flat on your y-axis and then went off. So it will look something like that if you're going to model it. So sometimes it is actually hard to tell, and so what we'll do, it was hard to tell whether you would use a quadratic or an exponential model in order to model something. And so what you'll have to do is look at a residual plot. So you'll see that on this exponential residual plot, you have all of these points down here that are really kind of creating a pattern. But if you look at the quadratic residual plot, you'll see that there's not too much deviation from the pattern here, which makes us believe that this is actually going to follow a quadratic relationship. It's going to be better modeled with a quadratic relationship. All right, so let's go ahead and put this all into use. So we're going to use our TI-84 calculator to put this data in. So we'll put this data into a table where this is going to be, of course, our L1. It's our explanatory variable. And this will be L2, our Y, or our response variable. So we'll enter those in, and we're going to go ahead and graph it. And then do the exponential regression. We'll also do quadratic regression and decide which one of those models fits this data the best. So let's get to it. Let's get out our calculators. So here I have my handy dandy calculator. I am going to go to stat, and then I'm going to edit. And I need to edit my L1 and L2. So first of all, I need to clear it. So clear, enter. That'll get rid of that. I'll move over, go up to L2, click clear, and enter. And now we've got these things all ready to enter the data. So let's do that. Excellent. So I went ahead and entered that data in there for you. This is what it should look like. Go ahead and take a minute to get that data in your calculator. So now that you've done that, I'd actually just like to look at the relationship to see what's going on. What does it look like? What type of curve does it look like? So let's go ahead and actually graph this. So in order to do that, we're going to hit second. And we're going to go to y equals. Second y equals takes us to our stat plot. We need to make sure to turn stat plot 1 on. So I'll turn that on. Make sure that our x list is L1 and our y list is L2, and that we are doing a scatter plot. Everything looks good. So we'll go ahead and hit graph. We'll notice that there's nothing there, and that is because we need to actually change our zoom settings so that we're looking at statistics. So we'll change that to zoom stats. Hit enter. And there it goes. So gosh, it could be an exponential or a quadratic model. Who knows? We'll have to see which one is the better fit. Off the bat, though, this looks a lot like it's going to follow a quadratic model. But really, the only way for us to know for sure whether this is going to be modeled by a quadratic or an exponential regression is by calculating the models and looking at our r-squared values. So let's go ahead and do that right now. So let's go ahead and start with the quadratic regression. So this is how we're going to do it. We're going to go to stat. We're going to go over to calc. I'm going to look for quad reg there. We'll select that, number 5. And then just go down to calculate. As long as we know that our x list is L1 and our y list is L2, we'll hit calculate. And let's see how we're going to write this down. Okay, now that we've got that data, let's jot it down. Okay, by the way, we haven't even talked about what this is. It's has to do with people's age and the premium that they pay, right? So for life insurance, they charge older people more money because they're more likely to die, and they actually have quite a bit of probability that goes into deciding exactly how much they're going to charge for a premium. So let's go ahead and jot down. So we're calculating a quadratic model for these data. Let's write this down on the next page. So what we had here was we had A was equal to 37.9 or 0.379. So we'll write, so we'll be in the form y hat, your predicted value, is going to be equal to some ax squared plus bx plus c. So when we put all of those in there, it's going to be y hat is equal to 0.379 x squared minus 31.191, right, because that was the negative, plus 674.95. There we go. And let's make sure we record this r squared value that we have. Our coefficient of determination is 0.992. All right, so now let's answer number 2, and we'll calculate the exponential model for these data. So let's go back to our handy dandy calculator. And now we're going to hit stat again. And we have that list already in there. So we're going to go over to calc. And you don't see it right on the screen, but one more down gives us xreg, which is for exponential regression. So we'll hit enter on that. Make sure that our x list is L1 and our y list is L2. It looks good. And we'll click calculate. And we'll make sure to record these values for a, b, and r squared in this case. Let's go ahead and write down those values, keeping in mind that our exponential regression is going to be in the form y hat equals a b to the x power. All right, so then inputting those values that we had for a and b, we have 0.939 times 1.090 to the x power, all right? And we had an r squared value of 0.999. Excellent, so that answers 1 and 2. For number 3, we were asked which would be the most appropriate to use. And in order to answer that question, we're going to look at both of these r squared values. So we'll notice that this r squared value that we're circling now is higher than the r squared value for the quadratic model. Right? That means that there is a stronger correlation, or in better terms, right, this r squared value of 0.999 says that 99.9% of the variation in our response variable can be accounted for by this regression model. And we want this to be closer to 1. So since 0.999 is closer to 1 than 0.92, we would use the exponential model. All right. And it's because of this really high value, or not really high, but higher value. Fantastic. Let's look at where we are at next. Number 4. So using our chosen model, we're going to calculate and interpret the residual for the 65-year-old. So that means that what we're going to be looking at is this entry right here. We're going to construct and calculate the residual for this particular point. So let's go ahead and do that. Number 4. Remember that our residual is our observed or actual minus our expected value, okay? So we are going to need to figure out, what is this? So we know that y is our y variable here. So this is going to be our y. We need to use this x in our regression equation to figure out what our predicted value is. So we're going to plug 65 in right there. Okay, so let's calculate that real quick. what is y hat, our predicted value for that? And I think I might write that right there. So y hat, so we're going to look at 0.939 times 1.090 to the 65th power. We're going to see what that is. So I put that into my calculator, and I got that this is going to be 254.324. Awesome. So now to fill this in, and I think that that's kind of a strange to get rid of this. Oops. Get rid of this here. It's a little weird. All right. So our y value we got from over here, I said it was 257. So 257 minus 254.324 is going to be equal to 2.676. And this is our answer. This is the residual. Something weird. Sorry, and here we go. This is our residual. All right. So have we answered the entire question? It appears that we have. Fantastic. So we got all of these things done today. Thank you guys so much for watching. I hope you're having a fantastic day, and if you're not, I really hope it gets better.